Good morning. Welcome to Current STEM World. In this video, let us see what are called nanomaterials, what are the different types of nanomaterial, 1D, one-dimensional, two-dimensional, three-dimensional, zero-dimensional, quantum are called quantum dots and optical properties. So what are nanomaterials? Any material having at least any one dimension lies in a range of 1 to 100 nanometer is called nanomaterial. Okay, the range of nanomaterials do not have clear boundaries because some people say 1 to 50 nanometer, some people say 1 to 120 nanometer. The scale range of nanomaterials do not have clear boundaries. Such nanomaterials have distinctly different physical and chemical properties from their bulk. They have distinct properties from their bulk. In the nanometer scale, these properties often differ from its macro scale level due to quantum mechanical confinement effect. That is called quantum mechanical effect. Quantum effect. Okay, what is nanoscience and nanotechnology? It is recently very popular and it has lot of potential applications. It deals with the study, fabrication of nanomaterials at its atomic, molecular and cluster level and their applications in various industries and medicine, biotechnology, etc. Okay, now let us see the dimensions of nanomaterials. We have 4 dimensions. 3-dimensional nanomaterials. Okay, these are 3-dimensional nanomaterials. They have length, breadth and height. Breadth, length and height. Those nanomaterials in which the edge length of all the 3 dimensions is greater than 100 or equal to 100 nanometer. Okay, what are 3D nanomaterials? Those nanomaterials in which the edge length, see the edge length of all the 3 dimensions is greater than 10 nanometer. Okay, now what are called 2D nanomaterials? Okay, let us take a sheet only. This is 2D. Okay, this is 3D. This is 2D. Those nanomaterials in which the edge length of one dimension is less than 10 nanometer. See, you have X, Y and Z. Z is the dimension, one dimension less than 10 nanometer. Okay, let us now see one-dimensional nanomaterials. Okay, let us take a strip of it. Okay, this is called one-dimensional nanomaterial. Those nanomaterials in which the edge length of 2 dimension is less than 10 nanometer. Okay, then you take only a point. 0-dimension quantum dots. Those nanomaterials in which the edge length, opposite of this, in which the edge length of all the dimension is less than, here it is greater, here less than 10 nanometer. These 0-dimensional nanomaterials are called quantum dots. Okay, gold nanoparticles, silver nanoparticles, they are all examples of quantum dots in which the edge length of all the dimensions is less than 10 nanometer. Okay, now we will see certain examples. What are 2-dimensional nanomaterial? For example, graphene, carbon nanosheet. Okay, you see here, this is the structure of graphene. they have layered, hexagonal layered structure. There are several layers stacked, okay, separated by 0.33 nanometer. Now let us slice only one sheet, that is a single layer of graphite crystal is called graphene. This is called graphene. This is the structure of graphene. One dimensional nanoparticles, nanomaterials, carbon nanotubes, for example, one dimensional. Okay, you see here the cylindrical form of, if you roll up graphene nanosheet, you will get carbon nanotube. Okay, so cylindrical form of graphene 2D nanosheet is called carbon nanotube. These carbon nanotubes may be open at both the end or closed at both the end, or may be open at one end and closed at one end. Okay, now single walled, there are two types of carbon nanotube. One single walled carbon nanotube. How it is obtained? Graphene, a 2D nanosheet, is rolled up to give single walled carbon nanotube. Okay. Now the other type is called multi-walled carbon nanotube. In this graphite, a multi-layer is rolled up into carbon nanotube called multi-walled carbon nanotube. Okay, now let us see what are nanowires. These are all nanowires, are one-dimensional nanomaterials in which the length of the material is more than 100 times the diameter of the nanomaterial. This is the diameter. So one-dimensional nanomaterials in which the length of the material, see, length of the material is 100 times more than the diameter of the material. Now what is nanorod? It is just opposite. One-dimensional nanomaterial in which the length of the material is more than, here the length of the material is less than 100 times the diameter of the material. So they are called nanorods. Okay, let us now study the optical properties. For example, gold nanoparticles, they are different colored in different size. Okay. Optical properties of nanomaterials therefore strongly dependent on size, shape, surface functionalization, doping and interactions with other materials. For example, the different colors of different sized carbon nanoparticles, you see, different sized gold nanoparticle, they are different colored. It is due to change in the optical band energy gap, and hence the surface plasmon resonance properties of the nanomaterials. Okay, the optical band gap increases with the decrease in, you see, the band gap for bulk material. This is the band gap, and this is the band gap for nanoparticles. The optical band gap increases with the decrease in particle size due to quantum confinement effect. Okay, that is quantum effect. The particle behaves like quantum particles. That is, they behave quantum mechanics. They obey quantum mechanics. In bulk, they obey classical mechanics. In nanoparticles, they obey quantum theory. So the optical band gap increases with the decrease in particle size of nanoparticles. Thus, the colloidal gold or silver nanoparticles produce different colors for different sizes in the range of 1 to 10 nanometer because of the change in energy band gap. As we see in the bulk state, this is because, see, in the bulk state, there are more number of atoms than in nanoparticles. In nanoparticles, there are less number of atoms. Here, in bulk, there are more number of atoms, therefore more energy levels, and the bands are overlapping, and the energy gap is very less in the case of bulk. Whereas in the case of nanoparticles, that is, they have less number of atoms. Okay, so there are less valence band and conduction band. Therefore, the band gap increases as size decreases. This is what I am saying here. Okay, so this change in band gap and wavelength results in the change in absorption spectrum, optical spectrum, surface, plasmon resonance properties, and color of nanomaterials. Thank you for watching. Please share and subscribe. Thank you again.